Hi everyone. So we'll start from in our last class we have started talking about transformation of trig functions. And we have seen a couple of examples in our last class on Tuesday. Now we'll start talking about um actually not this one, from this example that we can see here. The example 7.4. Now in this example, as you can see here, 1 y equal 1 minus 2 sine x. And as we have reviewed in our last class, any operation that happens inside the function with the variable that has, for that, we change our x coordinates. And any operation that we do outside the function, which that because of that, we change our y coordinate. So in terms of the transformation, as we have learned, I'll go back a little bit. As we have learned here, that we can have horizontal shift, horizontal shrink or stretch, vertical shrink or stretch, and vertical shift. And according to the order, horizontal shift will be the first one that we'll check, and then we'll check for the horizontal shrink or stretch, and then vertical shrink or stretch, and the last thing we'll do is the vertical shift. Okay, now by following that, we'll move forward to the example 7.4. As we have seen the 7.2 in our last class, and as we have went over this example where I'll actually go back a little bit. Yeah, so in this example, as we have seen, we are having horizontal shrink or stretch as we are multiplying by a constant 3/4 inside the function. So that's because of that, we'll have horizontal shrink or stretch. Since the constant 3/4 is in between 0 to 1, so we will have, so it's in between 0 to 1, so we are going to have horizontal stretch, right? And whatever happened inside the function in terms of operation, we follow the opposite of our intuition, right? So here in the first two columns of the table, we are listing for the parent function cosine x. For cosine 0, we get 1. For cosine pi by 2, we get 0. For cosine pi, it's -1. Cosine 3 pi by 2 is 0. Cosine 2 pi is 1. Right? And in the graph, as you can see, the horizontal axis is marked as all the angles of our trig. So 0 to pi, 2 pi, 3 pi, 4 pi, so on. And in the vertical axis, we are listing all the output for the corresponding trig function angles according to our trigs. So since we are multiplying by the constant 3/4 inside the function, so we'll do the opposite here in our x coordinate. So our x coordinate will change because of the horizontal shift, and we'll change all the x coordinates by dividing by 3/4. Notice that the y coordinates will not change at all. That's because from outside of the function, we are not doing any operation. No vertical shift or no vertical shrink or stretch, because we are not adding or subtracting any constant from the outside, or we are not multiplying anything from the outside either. So there will be no change on the the y points, right? All right, now we'll simplify them. Dividing 0 by 3/4 is just 0. Dividing pi over 2 by 3/4. We simplified each of these in our last class. I'm hoping we know them already. So what we do, we change this division to a multiplication, and we flip the numerator and denominator, right? And then we simplify. If we simplify pi over 2 divided by 3 over 4, there will be 2 pi over 3. Dividing pi by 3 over 4, that's 4 pi over 3. Dividing 3 pi over 2 by 3 over 4, that's 2 pi. And dividing 2 pi by 3 over 4 is 8 pi over 2. So these are our new angles. Okay? And then the y coordinates will not change. They'll be similar. 1, 0, negative 1, 0, 1. But notice that again, all the x points from 0 is still 0. The pi by 2 is now changing to 2 pi over 3. Pi is changing to 4 pi over 3, so on, right? And so now we'll try to plot it. So first of all, 0. For 0, we have the value 1. For angle being 0, cosine 0 is 1. Cosine here for 2 pi over 3, we got 0. For 4 pi over 3, we got negative 1. For 2 pi, it's 0. For 8 pi over 3, it's 1. Okay? So what's happening is that when we are multiplying by any number inside the function 3 over 4, the corresponding angles are changing. So the x coordinates are changing, but not the y's, right? Now we'll add these points to get the graph. Now notice that previously for the parent function, cosine x, our one full cycle was from 0 to 2 pi, which is now getting stretched, and it's from 0 to 2 pi, it's now becoming, the one full cycle is becoming from 0 to 8 pi over 3, right? Okay, so that's our graph, and the graph is continuous in both directions. Okay. Moving forward to the next example, exactly similar, and we have seen this example before. So I'll start directly. So we are having y equals sine x minus pi. So we'll check what kind of transformation we are having here. So the only thing happening is that we are subtracting pi from the x. That means we are subtracting a constant inside the function. We are not multiplying by anything inside the function, or not multiplying anything outside the function, or adding or subtracting anything from the outside of the function. So the only thing is happening is a horizontal shift by pi units. Since we are subtracting pi, that means we are moving to the right. So the 0, from 0, we are now shifting to pi. Does this make sense? All right, so first of all, in the first two columns of the table, we'll list all that shorter form of our sin x table. So here comes our sin x table, which is for sine 0, we have 0. For sine pi by 2, it's 1. For sine pi 0, sine 3 pi by 2, negative 1. Sine 2 pi is 0. Now, since we are only having some horizontal shift, so we will only change our x coordinates, but will not change the y coordinates at all because there is no operation from the outside. All right, so according to that, we'll now, since we are moving to the right by pi units, we'll add pi with each of our angles, each of our x coordinates, right? And so by that, all of our x coordinates are changing from 0 to pi, pi by 2 plus pi, so which is 3 pi by 2, 2 pi, 5 pi by 2, 3 pi. And the y coordinates are still remaining the same. Okay, now we'll plot our transformed trig function. Okay, so for, first of all, notice that for pi, it's 0, and the pi is here. And for 3 pi over 2, it's 1. For 2 pi, it's 0. 5 pi over 2, -1. 3 pi, 0. So what's happening is that our one full cycle from 0 to 2 pi, it's now shifting by pi units, and it's moving from pi to 3 pi, right? And so now we'll add those points to look at the graph. But again, please remember that sine is continuous in both direction, right? Okay. Now it also says plot all the points corresponding to x-intercept minimum, maximum within one cycle, right? Okay, so that's what we already have here. As you can see, the maximum and minimum of these of our sine function here is still the -1 and 1, right? Okay, let's move forward to our next example. So moving forward to our next example, we are trying to graph 1 minus 2 sine x. So in order to plotting the corresponding x-intercept minimum maximum within one cycle, which means from 0 to 2 pi, we already have our sine table for that. So x-intercepts are this point, these, and then minimum, maximum. Okay. Now, in this function here, from the inside, we are not adding, subtracting anything, or multiplying anything. So there is no horizontal shift or no horizontal shrink or stretch. But from the outside of the function, as we can see, we are multiplying the sine x by -2, and also we are adding 1. So we do have vertical shrink and stretch. The negative correspond to the reflection, and adding 1 correspond to vertical shift. Okay, so now recall the order of operation. According to the order of operation, the first one was horizontal shift, then horizontal shrink or stretch, then vertical shrink or stretch, and the last one is vertical shift. Following that, we will, since there is no horizontal shrink or stretch and horizontal shift, so the first thing we'll do is we will multiply each of our y coordinates by -2. Again, remember that all the operations are happening outside, so only our y coordinates will change. There will be no change on our x coordinates because there is no operation inside the function. So according to the y coordinates, we'll multiply by -2 first because the vertical shrink or stretch comes before vertical shift. And then we will add each of them by 1. Please follow the order. Now let's simplify. Again, the x coordinates are not changing, but the y coordinates are changing. So the first one, 0 times -2 is 0 plus 1, which is 1. The second one, 1 times -2 is -2 plus 1 is -1. And then 0 plus 1 again, which is 1 for pi. -1 times -2, which is +2 plus 1, which is 3. 0 times -2 is 0 plus 1 is 1. So these are all our points. Right? So we are having vertical stretch. So the graph is getting taller, and reflection, and we are moving 1 unit upward vertically for the vertical shift. Yes, so that's our graph. After considering all the operation that we have, so the graph, notice that the graph is vertically stretched. It became taller. And then also notice that the minimum value of this function, of this transformed function, is now -1, and the maximum it's getting is 3, right? Okay, I hope it makes sense. All right, now let's move forward to our next example. So before even we move to our next example, here is a barcode for the Desmos. So you can scan this and you can view the graph for 1 minus 2 sine x, the transform function that we are given. Now notice that in terms of this function, we are still looking at the same function, 1 minus 2 sine x. What's happening, how we are plotting the function, right? So the first thing we are doing, we are starting with our parent function, y equals sine x, right? So one cycle is from 0 to 2 pi. Okay? So that's our function from 0 to 2 pi. And then the next thing we are doing is we are stretching the graph vertically by a factor of 2. That's because we are multiplying by 2, right? So here the number we are multiplying by is 2, not considering the negative because the negative corresponds to the reflection. Okay? So the graph got stretched by the factor 2 vertically because we are multiplying by the number 2 from the outside. Next, we'll consider the reflection. And so we'll reflect the graph over x-axis. Please notice the difference. Okay? So that was our graph previously before the reflection. It started from 0, the highest peak here at pi by 2. Then at pi, it's 0 again. Then lowest peak at for 3 pi over 2, and at 2 pi, 0 again, right? It's getting reflected over x-axis. So that's what we are having after the reflection, right? Now it's for pi by 2, now from the peak is getting reflected over the x-axis and so on, right? Finally, we'll consider the vertical shift. So 1 unit upward. So we'll take the graph and we'll move it 1 unit upward. So now we'll start from -1. Okay, we'll shift the graph vertically 1 unit up. So now it's starting from y equal -1, right? That's the final graph we have found previously by tracking the vertical shrink or stretch and vertical shift onto our angles and of course onto our table of sine x, the parent function, right? Okay, I hope it makes sense. If you still have some question, please let me know. Now let's move forward. Moving forward, that's our next example. Pretty similar. We are still looking at the transformed function. The given function is 3 cosine 3 over 2x minus 1. Now let's see what's happening. What's happening inside the function? That's what we'll see first. So inside the function, we do not have any horizontal shift because we are not adding or subtracting anything, but we are multiplying by 3 over 2, right? So we are having horizontal shrink or stretch. So for that, first of all, that's our shorter table of the cosine x for the maximum 1, minimum, another max, and the x-intercept. So these are all the points for one cycle from 0 to 2 pi. Now, in terms of the x-coordinate, since we are multiplying by 3 over 2 inside the function, so we'll divide each of these points by 3 over 2. Okay? All right, and so now let's simplify them. Dividing 0 by 3 over 2 is 0. Dividing pi over 2 by 3 over 2 is pi over 3. 2 pi over 3, pi, and 4 pi over 3. Now let's see what's happening outside. So we are multiplying by 3 from the outside. So we'll multiply each of the y values by 3. And then we are subtracting 1. So vertical shift, right? So let's subtract 1 from all the y coordinates. And now let's simplify. So we'll have 1 times 3 is 3, subtract 1 is 2, negative 1, negative 4, negative 1, and 2. Right? Now let's graph it. So in terms of graphing, we are graphing this, right? So our transformed function. So for 0, it's 2. For pi by 3, negative 1. For 2 pi by 3, negative 4. For pi, negative 1. For 4 pi by 3, 2. Okay, notice that the shape of the graph is changing. Also, we are moving 1 unit downward for the vertical shift. Okay, so that's our graph after the transformation. So notice that our one cycle from 0 to 2 pi is now changing from 0 to 4 pi, it's changing from 0 to 4 pi over 3, right? So it's from here to here is our new cycle. It's getting vertically stretched. Okay. All right. Let's move forward. Now, moving forward, we'll talk about some informations in terms of our the transformed trig functions that we have already seen. First of all, amplitude. So the amplitude, what is that? The amplitude of a periodic variable is, so I want to say that please know that the trig functions, sine, cosine, they are periodic function, right? So the amplitude of a periodic variable is the positive distance from its vertical center to its maximum or minimum, right? Once again, from the the distance from the positive distance from the vertical center to its max or min. You can think of any direction. Okay, now to calculate the amplitude, what we can do, we can use this. We subtract the minimum from the maximum and we divide it by 2. Okay, so saying that, notice that in terms of the sine or cosine both, the maximum is 1 and the minimum is 1, right? So what is our amplitude then? So maximum is 1, minimum is negative 1. So it's subtracting negative 1 from 1, dividing it by 2. So that means we get 2 divided by 2, which is 1, right? So our amplitude is 1 for the parent function y equals sine x and y equals cosine x. Okay? Now, if we have this transformed function y equal a sine bx minus c plus d, or y equal a cosine bx minus c plus d, as we have learned about all these coefficients already. So this c is horizontal shift, horizontal shrink or stretch, vertical shrink or stretch, and vertical shift, right? So once again, C represent horizontal shift, B represent horizontal shrink or stretch, A represent vertical shrink or stretch, D represent vertical shift. And so according to that, let me erase that so that you can see them clearly. By that, the amplitude for these transformed functions will be absolute value of a. That means the constant we are multiplying from the outside. And we are considering absolute value because we don't want to consider the negative, if there is any, because the negative will correspond to the reflection. All right. So once again, the absolute value of a is our amplitude. Okay. Moving for, as you can see here in the parent function, though, we are not multiplying any number from the outside, right? That means the amplitude is just 1. Moving forward now, let's talk about the period. So the period, also called the wavelength in physics, what does it do, right? The period is a cyclic of a cyclic function is the smallest positive number p for which the f of x plus p equal f of x. Means that is the positive distance for one cycle of the function. You can think of a peak to peak. That means what is the positive distance for one full cycle? For example, for sine or cosine, what is the period? What is our one full cycle? 2 pi, right? Yeah. So one complete cycle, one full cycle for sine or cosine is 2 pi. And for any transform function, how do you know that what is our period? What is the one positive distance of one full cycle, or the distance from peak to peak, right? How do you calculate that? For that, since for the parent function sine x and cosine x, the full period is 2 pi, to calculate the period of any transformed function, we calculate 2 pi divided by absolute value of b. What does the b again? The b is the horizontal shrink or stretch, the constant we are multiplying inside our function. All right. Once again, to calculate the period, we divide the 2 pi by absolute value of b. All right. Let's move forward. Next, the phase shift. So the phase shift is a horizontal translation of the starting point of a graph. That means, for example, as you know that the graph in terms of our sine function starts from 0, right? Yeah. So the starting point of the graph, which may also include the effect of the horizontal shrink or stretch with the horizontal shift. Okay, once again, the phase shift is the horizontal translation of the starting point. So since our sine x starts from 0 at the point from the origin from 0, right? Now, if after the translation transformation, my graph is now starting from my starting point 0 is moving here, that means that's going to be my phase shift. Okay, I hope it makes sense. So if we just have a horizontal shift, let's say by pi units, as we have seen one example before. So then my starting point 0 is moving to pi, right? So that's my phase shift. Now again, that's correspond to both horizontal shift and horizontal shrink or stretch if you have both. Now, in terms of if we consider this function y equal a sine a times sine bx minus c plus d, considering horizontal shift, shrink or stretch, vertical shrink or stretch, and vertical shift, then to calculate the phase shift, what you can think is that what if we factor out the, let me change the color. What if we factor out the vertical horizontal shrink or stretch b? If we factor out the b, then what do we get? So if we factor out the b, we get with the sign, we get b times x minus c over b, right? Now this is our phase shift. So once again, if you're looking at this transform function to calculate the phase shift, what we will do, we'll divide the C by B. That's our phase shift, okay? All right. Now let's move forward to some examples. Moving forward to some examples. First of all, here on the 7.6, we are trying to find the amplitude, period, and phase shift of the function, given the exact values, not decimal approximation. All right. Now here, first of all, is given y equal -1 minus 3 sine 3x minus pi over 4. Let's find the amplitude first. Okay, what do we have just learned for amplitude? Amplitude is going to be the absolute value of A. What is A? A is the number we're multiplying our trig function from the outside. So amplitude is going to be absolute value of A, which is absolute value of -3, so 3. Now let's calculate the period. For the period, what do we check? Okay, I'll go back. So the period was 2 pi over absolute value of B. Okay, so we divide, since one full cycle for the parent function is 2 pi, for the transform function, we divide the 2 pi by the horizontal shrink or stretch, right? So period is going to be 2 pi divided by absolute value of B. Here we have 3 for the horizontal shrink or stretch compound. So we'll divide 2 pi by absolute value of 3. So 2 pi over 3 is our new period. Finally, the phase shift. For this phase shift, what we do? We calculate the C divided by B, right? So here C is pi over 4 and B is 3. So for phase shift, we'll divide the pi over 4 by 3, right? So that's pi over 12 is the phase shift. Okay. All right. Let's move forward. Now, moving forward, that's just the example we have seen. We have calculated the amplitude, period, and phase shift. There's the barcode you can scan and go over to the decimals to visualize the graph. Now, just to notice all these amplitude, period, and phase shift in our graph, first of all, for amplitude, okay? So it says amplitude is 3. That means, as we have learned by the definition, for calculating the amplitude, what can we do? We subtract the minimum from the maximum. So we subtract the minimum from the maximum and we divide it by 2. Now, if you subtract -4 from 2, we get +6. And if you divide +6 by 2, we get 3, right? That's our amplitude, right? So now notice that the amplitude is this distance, 3. Okay? The positive distance from the vertical center. Now here, even though I'll go back, even though that's our graph, that's the center is here at 0, but the vertical center is not here anymore. Because of the vertical shift, we moved 1 unit downward. And so our vertical center is at -1. Okay, and the distance from the vertical center to the positive distance from the vertical center to the max or mean is here 3, which is our amplitude. We have already calculated. For the period, so for one cycle for the parent function, it was 2 pi, but now our period is changing to 2 pi over 3, right? So notice that here, from the highest value that we have here on the vertical line, okay? On the vertical line starting from 1 to here, okay? And that's 2 pi. This distance from here to here is 2 pi. All right. Sorry, 2 pi over 3. I meant to say 2 pi over 3. Okay, next, the phase shift. So the phase shift, as we check, is that where does the origin starting point is moving, right? So notice that here, our original graph for the sine x starts from 0, right? It starts from 0 um, so sine 0 is 0, right? But now it's moving. So going back to the definition of phase shift, uh, our starting point is moving by the unit c divided by b, which is pi over 12. So our starting point is moving to pi over 12. Okay, so that's our phase shift. All right, so that's just for the visualization of what we have calculated here. Now let's move forward to the next example. Here we are trying to write an equation of the form either y equal a sine bx or y equal a cosine bx. We do not know what we are having. We need to figure out depending on the graph we see below. Right now, let's notice the graph. What do we see? We see that the graph is starting from the 0. Both x and y values are 0, right? And so now, since the graph is starting from 0 and the corresponding value for the angle 0 is 0, and for which function that happens, sine or cosine? Sine, of course, right? For cosine, for the cosine 0, it's not 0, right? So the first thing we'll do is we'll choose the function. Is it sine or cosine? So we have seen by the behavior of the graph, it should be sine, okay? So again, it's starting from 0, 0, so it should be sine function. Then we'll calculate the amplitude. That means, as you can see, that's the vertical center. And by these that's the vertical center here, the horizontal axis. And in both sides, we are having the same distance. And so the amplitude will be the distance from the vertical center to the max or minimum, right? Which we can see is that from 0 to 3.5. And again, we can just calculate maximum. So the maximum subtract the minimum and divide it by 2, right? So if you subtract 3.5, negative 3.5 from 3.5, it will be positive 7. And if we divide it by 2, it'll be 3.5, right? That's our amplitude. And so in terms of this function, as we can see here, a corresponds to the amplitude, correct? So which is 3.5. So we can write that amplitude absolute value of a is 3.5 or 7 by 2, right? That means, so our a is 3.5. I'll just erase here a little bit to clear up the mess. All right, perfect. Now we'll notice our period. That means, okay, now here, let's try to calculate the period. Okay, so one full cycle for the parent function is 2 pi. Now, what is one full cycle here? So from peak, you can think of like starting point here to what is the point here? Or you can still think the peak to peak, that works as well. If you think of peak to peak, so 2 pi to 10 pi, and the positive distance is 8 pi, right? Or from here, from 0 to 0 here, 0 to 8 pi, the period is 8 pi, either way, right? So period is 8 pi, and as we know for the period, we calculate 2 pi over absolute value of b, which is equal 8 pi here. So now let's solve for b because we do not know what is going to be our b here, right? What is the number we are multiplying here? Okay, now let's solve for b. We are doing cross product and then let's divide both sides by 8 pi. So we calculate the pi get cancelled and we get absolute value of b is 1/4. All right, so we almost have it. Y equal 3.5 sine 1/4 b. Only thing is that we need to decide if our a has to be negative and b has to be so the sign of a and b. That means are they going to be positive or negative? All right, that's the only thing we need to decide here. Now notice that here, if we look at the graph, as we can see that this is the part for 0 to 2 pi. That means here we have the first quadrant 0 to pi by 2, which is clearly a positive function, right? Positive. So the graph is positive for the first quadrant. Since the graph is positive for the first quadrant, that means both our A and B has to be the same sign. Either both has to be positive or both has to be negative. Okay? That's because if they both are positive, then the graph will behave normally. If they both are negative, then there will two reflections happen, right? Because of the negative b will reflect it over the x-axis. Because of the negative a will reflect it to y-axis, right? And by both reflection, the graph will get back to its normal shape. And so we can say that two reflections actually cancel each other and the graph behaves in the previous way. All right. So once again, since in the first quadrant, we can see the graph is positive. So either A and B are both has to be positive or both has to be negative. They cannot be in opposite sign. All right. So either has to be both A and B has to be positive or both has to be in negative. All right. Okay. I hope it makes sense. All right. Let's go over one more example. So here we have an application problem. It says a paddle wheel on a riverboat turns as the boat moves through the water. The vertical distance between the particular paddle on the wheel and the surface of the water is recorded. The vertical distance defined by d as a function of time t. Now notice that in the graph on the horizontal axis, we have recorded the time t. On the vertical axis, we have recorded the distance d. All right. Okay, now we are trying to answer some questions. The first one, what is the period in second of the graph? All right, so for the period, what do we do? Period means one full cycle, right? Now let's notice what is one full cycle here. Let's counter the peak to peak. What is that? From peak to peak, I can see time in seconds is 12. Yes? Okay, next question. Which of the following best describe the period of the graph as it relates to the paddle wheel? So the period, once again, the period here, so as we have calculated 12 seconds is our one period in that case, and that is correspond to time, right? So which one best describe the period? So the number of meters of the center of the paddle wheel The number of meters is for distance, not for time. So let's cross it. The number of times the paddle goes around the paddle wheel. Okay, that's correspond to time, but let's go over the other number of seconds it takes for the paddle. Okay, so it does not correspond to the number of times, it corresponds to the number of seconds because we are recording the time in seconds, all right? So number of seconds it takes for the paddle to make one revolution. The period means one full cycle. So how much time, how many seconds it takes for one full revolution? That's what corresponds to the period. That's what describes the period. Okay? Next question. What is the distance in meters between the center of the paddle and the surface of the water? Okay. So the distance between the center of the paddle and the surface of the water. Here, notice that this is our surface of the water, okay? That's our surface of the water. And what is our center of the paddle wheel? So the lowest point of the center of the paddle, the lowest point of the paddle wheel is -2. The highest is 22. So can we calculate the center? Let's subtract the minimum from the max. So 22 subtract -2 is 24, right? And if you divide that by 2, what do we get? 12, right? So that means the distance from the lowest point, and we need to count up to 12. So from -2, if you count up to 12, the middle point would be at 10. Am I correct? Here we have 12 and here is another 12, right? That's our midline. So once again, that's the surface of the water. That's our midline. All right. So now the question, what is the distance between the center of the paddle to the surface of the water? What is the distance from the middle line to the surface of the water? 10 meters, correct? Here, this is 10 meters. Okay. All right, let's move forward to the next question. It says relative to the surface of the water, which is here, what is the height of the paddle in 30 seconds? So in height of the paddles, all right, in 30 seconds. All right. So what we are actually looking for, this means that the so we are trying to see uh that what is, okay, once again, the height of the paddle for the time being 30 seconds. In my horizontal axis, it does not show me the record for 30 seconds. So we cannot see that for time being 30 seconds, what is the height, right? But we can calculate that. How? For that, we'll try to see what was our one period. Do we remember that? What was the one period? Peak to peak, correct? So peak to peak, one period that we have calculated was 12. That is our one period. All right. So, sorry, going backward. For one period, since it's 12, so what we'll try to calculate is that what is our D30, right? And that's what we're trying to calculate, distance for the time being 30. So that means the D30, that will be similar as D30 subtract 12, subtracting one period, or multiple of it, right? So D30, my apology for the worst writing here, it's just very not convenient. And multiple 2 times 12. Sorry, I meant to write 12. Okay, so these are all going to be equivalent. All right, so here 30 times 30 subtract 12 is D18. So that means the distance at the 18th second will be the similar. What is that? At time 18 seconds, what is the distance, as you can see? -2, right? Okay. Next, D 30 subtract 2 times 12 is what? D6. Okay, that's equivalent with the D30 as well. And for time being 6 seconds, what is the distance from the surface of the water? Sorry, what is the height from the surface of the water? -2, right? Yeah. So that's it. So that means -2 meters, -2 meters is the answer for this. Relative to the surface of the water, the height is -2 meters for at the time 30 seconds. I hope it makes sense. Okay. All right. That's just another example, but let me see. So let's stop here with this workout problem, and then we'll continue talking with the next examples in our upcoming class. All right. In the meantime, if you have any question, let me know, and I will upload the study guide by Thursday. So I meant Thursday, February 27. So I'll upload the study guide for the test 2, which is coming on March 6 by Thursday. In the meantime, if you have any question, please let me know. All right. I'll see you all next week. Have a nice weekend.